Welcome to Hope Academy. My name is Mr. O, and today I'm going to be going over specifically numbers 43 through 46 today for the SAT Crack SAT exam 1 for the SAT Math Level 2. As usual, I go over the problems real quick and then explain in depth how to do the problem. So I'm going to go ahead and get started. So 43. Okay, so number 43, my final answer is E, and now I'm going to explain to you how I was able to get to this answer. So for number 43 specifically, it's an idea based around sort of the idea of slopes in a sense, and so I'll explain what I mean by that. So this question I'm very familiar with. There's a lot of type of questions like this that do come out along the way, not just in SAT 2, but also in SAT 1. The idea is that for these two questions right here, they're asking what value can this not be? And the only time that two functions or two linear functions, which both of them are, do not have a solution is when they are parallel. So that means that whenever the x values and the y values sort of line up, that means that there is not going to be any answer because they don't intersect the two lines. And so what happens that right here, I notice that this 2 to 10 multiplies by 5. And so in order to create a scenario where this does not have a solution, I'm going to force this C to also be proportionally the same amount. So 3 times 5 will equal to 15. Thus, C cannot equal to 15 or else there will be no solution. Thus, based on the question what it's asking for, it's asking for that it has possible solution except for one of these, and it's going to be E. So it's going to be 15. And that concludes my explanation for number 43. I'm going to go ahead and continue on to number 44. So number 44. Okay. 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 Let's see, let's do that. I'm gonna grab my calculator. Okay, so that's A. Okay, to get B. So B 9.486, whatever not. And because of that, BC. Okay, this times this there's 284.6. Okay, so number 44, my final answer is C. In order to do this question, there's actually two ways to do this approach. The first method actually will have you sort of, guesstimate in a way where you could actually sort of guesstimate what possible values would A, B, and C be. And you could sort of logic it out and round off to eventually get to the answer C. But for this practice, I actually solved out for the values of A, B, and C just for accuracy purposes and for you to be able to see that it's possible to get to this answer. So what happened was that they tell you to set up that xy equals to this equation, and then they give you three different, possible equations. So I wrote them down right here. So I wrote down AB over 3 equals to 15 is the first one, BC over 3 equals to 20, and AC over 3 equals to 10 is my last one. These are my main three equations that will help me solve it out. And so what happened was that I ended up just solving for A, just as a personal preference, and thus I set up this one to get rid of B, and I substituted it into this B. So basically I took this value right here, and I plugged it into this B right here. But what happened was that also when I was dealing with the C, for example, right here, the C, I took that value and made it so that A is the variable I'm going to carry out, and I did substitution there too to get this equation right here. So this became my primary equation afterwards. And then afterwards I solved for A. Once I solved A, I could now use these other equations to AB equals to 45, BC equals to 60, and so on to solve out for B and C, and that helped me eventually get to the answer. And I did that sort of in the calculator, and that's how I was able to be for certain sure that my final answer for number 44 is C. And that concludes my explanation for that question. So I'm going to go ahead and continue on to number 45. So 45. Okay. Let's just call it A for now. That's an answer. If I carry that over, B squared 2A equals 2Y. Okay. Interesting. Square root both sides. I could get that. Yeah, I could definitely get this. No, that's not possible. And that's definitely not possible. So for number 45, my final answer for this question is B. And now I'm going to go ahead and explain to you how I was able to get to this answer. So when I was dealing with 45 specifically, I actually used just a logarithmic rule where I just copied down the question right here that they were asking. And I put A here for temporarily. It's not an actual answer or a value by any means. It's just a placeholder for me so that I could see what would happen if I play around with the log rule a little bit. And what I noticed is that I could carry this x squared up and I'll have y equals to x sub 2a. The thing that made me realize that that 2 would work is the fact that if I square root it, or aka times half both of these, I could have y to the half power equals to xa. So this will become actually y to the half equals to xa. And I could actually go backwards again, where I could recreate the log, and I'll end up with log a of the square root y equals to a. Log x, sorry, of the square root of y equals to a. And thus, that's very feasible. But the problem is that for 1 and 3, I could not see any other way possible to do that trick based on the log rules that I'm available to use, and thus how I was able to get to the answer of B. Other ways that I could see you doing this or solving this question out is that you could actually choose values for x and y. So for example, give x the value of like, let's say 1, and y, or like, yeah, and y the value of like, let's say 2. You could plug it 1 and 2 into here, and then keep plugging 1 and 2 into your x and y's to see which one actually gives you the exact same answer. And thus, that is another strategy you could use, but personally for me, I was able to just figure it out based on just the logarithmic rules. And that concludes my explanation for number 45. And to continue on to the very last question, so number 46. Okay. Okay. Let me clear out my calculator so I can do this. Okay. This R is going to be okay. Something around 15. Okay. Okay. So let's get 100, 400, 400 pi. So it'll be from 400 pi to, let's see. Difference. Okay, so for number 46, my final answer for this question is A. And now I'm going to go ahead and explain to you how I was able to get to this answer. So for this problem, the important thing that I noticed right off is that they talk about volume-based, sort of changes in a balloon, a spherical balloon. And then eventually what happens is that they convert and ask you to talk about the increase in the surface area of the spherical balloon. Okay, and so right off, I've noticed that the beginning thing I needed to know was this equation right here. This equation right here, the volume equals 4 over 3 pi r cubed, should be something you have memorized. If you did not memorize it, make sure you start memorizing these equations. And this surface area equation is also something you should know also. That being stated, it is not as commonly used in the math SCT2 practice, but just be aware that it is something that is used in these exams, and so just have it in the back of your mind. And so when I was doing this question, my very first step, what I did was that I just annotated. I just wanted to pull out key information and understand what's going on. And so that's what I exactly did. I noticed that 4188.79 to 14137.67 cubed was going to be occurring as like the sort of question, and then went to 12 seconds. But now I'm going to go ahead and explain on a separate piece of paper as to why that's so important. So when I'm doing this sort of work, the 4188.79, the conversion, and I do want to explain what I did right here. So I'm going to copy it down here so it's more clear. And it goes to here, 14137.167 cubic centimeters. The thing you need to do is not to change this by like square rooting it right off and whatever not. What you actually need to do is to find the radius for the volumes for each of these balloons and then reconvert it to a surface area based equation. And so that's what I exactly did. I understood that I needed to solve out each part, and I'm going to do this in different colors so it'll be easier to follow along. So what I did, and I'm going to push this up, is that I just simply did was 1488.79, made this equal to 4 over 3 pi r cubed as one equation. And then for my other equation, I did 14137.167 equals to 4 over 3 pi r cubed, and that would be my second equation. And so when I was doing these equations, what happens is that I could solve for two different radius values and then reconvert it back into the surface area equation. So I'm starting from here, getting the radius value, and then switching over to the surface area. And so now I'm going to go ahead and do so. So right here, I basically did was first thing first, I understand that I have to multiply 3 over 4 to get rid of that 4/3. So I multiplied both sides by 3 over 4, and that's what I exactly did. And then after I did that step and reconverted it, what I simply did afterwards was divided by pi on both sides as the second step. And then eventually I just cubic root both sides. Okay, so cubic root and cubic root. Be aware that you should just do this step by step, and that's what I did on the calculator. And what it resulted was that I ended up with a radius value for this orange portion right here equals to 10. And then it's similarly on this part right here, I did the exact same thing. So I first did was 4 over 3 on both sides. 4 over 3. Oops, no, 3 over 4. Sorry about that. 3 over 4. Multiply 3 over 4 here, and then I divided by pi on both sides again, divided by pi, and then I cubic rooted it afterwards as the last step. And so what happens is that when I do this sort of steps right here, I ended up with the radius. It wasn't as clean, this answer in the end for this particular question, but I ended up with a radius of 15 from what I recall. Yes, I did. And so what happened was that afterwards, what I did was that I plugged these back into these equations as surface area. And so as a reminder, the surface area equation will be 4 pi r squared. And I'm going to recopy that on here as this color so you could follow along. 4 pi r squared. And then so I plugged in 10 and 15 into these radiuses. So I plugged it into here, and then one second, I'm just checking to make sure that the values are correct what I get. So once you plug in r as 10 into here, what your volume, not volume, whoops, I meant to write surface area, so let me edit that real quick. So right here, surface area and surface area. And so what happens that afterwards, when you're solving for these surface areas, I plug them into here, and I actually got a surface area right here. Surface area equals to 400 pi, no, yes, I did. So 400 pi ended up becoming the result for this. And for this one, the surface area became 900 pi, okay? And so now that I'm in surface areas, the question asks what's my rate of change after those 12 seconds, I believe, yes, 12 seconds, and what happens afterwards. And so the question is that what's going on in these 12 seconds to tell me the rate of change for surface area. And the way that I could figure that out is I find the difference between 900 and 400. And so the difference between 900 and 400 is going to be 500 pi. And so I simply did was 500 pi divided by 12. And that eventually gave me the answer of 130.9. And that will be my answer for centimeters squared per second. And that will be the answer for this question. And that concludes my explanation for number 46 and for today. Thank you so much for watching this video. Please do subscribe to our YouTube channel, like our Facebook page, follow us on Twitter so that we can continue to make content like this. I hope you have a wonderful day.